Welcome to my YouTube channel Happy Physics. Be happy always. So today our main topic is radioactivity and subtopic mass energy equivalence. According to Einstein, the mass and energy are interconvertible. It means mass can be converted into energy and energy can be converted into mass. So according to this relation, mass is a form of energy. In order to study this relation in detail, Einstein gave an equation that was E is equal to mc squared. So here E is energy measured in joule, mass measured in kilogram, C is speed of light that is measured into meter per second. The famous examples of E is equal to mc squared, if you are looking for an example, where we can apply this relation, then two famous relations. First is fission and second is fusion. Later on, I will teach you what is meant by fission, mean breaking up of matter, and what is meant by fusion, joining up of matter. Now, for example, all this will happen inside the nucleus of a radioactive element. So, if you would like to represent a nuclear reaction, we have to know about the nuclide notation. Yani for example, this is A and this is Z, and this is A, we call it mass number or nucleon number. Nucleon number means the number of proton plus number of neutron inside the nucleus of a radioactive element, and Z we call it proton number, and it is equal to number of proton or electron present inside an atom. After that, we should know about another thing, and that is very interesting. Let's say we know that an atom consists of three fundamental particles: proton, positive charge; neutron, no charge; electron, negative charge. We know that the proton and neutron are present inside the central solid region of an atom. This is nucleus. So inside the nucleus we have proton, positive charge; neutron, no charge. All together we call it nucleon are present inside the nucleus of an atom, and this is the electron revolving around the nucleus in their respective orbits. So this is electron, and electron is present inside the orbit. So according to atomic structure, let's say this is the nucleus and this is an orbit. So inside the nucleus we have proton and neutron, and electron are revolving around the nucleus, and this is an atom. If we are able to calculate the mass of an atom, let mass of an atom is equal to m1. So this atom is consist of proton, neutron and electron. So first of all you have to calculate the collective mass of an atom experimentally, and then this is number one, for example. And secondly, if you are going to calculate the mass of individual particles, yani you calculate mass of proton plus mass of a neutron plus mass of electron. So in this case, this particular atom is consist of one proton, one neutron, and one electron. So the mass of an atom m1 and mass of individual particles, that is mass of proton, mass of neutron, and mass of electron, is, for example, m2. We can write here unit, m1 unit and m2 unit. So according to a layman, if proton, neutron and electron are all together, and if proton, neutron and electron exist independently, then there should not be a difference. What is this difference if they exist independently or in the form of an atom? But experimentally it was observed, when the proton, neutron and electron, they form an atom, they appears to be lighter as compared to their individual masses. So all this will be heavier as compared to atom. So it means the mass of the particle is greater than the mass of an atom. So it means there is a mass difference. Mass difference means there is a difference in mass. Difference in mass, and this difference in mass is known as mass defect. It means if a proton, neutron and electron exist independently and you combine the collective mass of all these particles, it appears to be heavy. It is heavy as compared to when they form a nucleus. It means as soon as these particles combine to form an atom or nucleus, their mass decreases, and this decrease in mass is known as mass defect. So if you would like to define mass defect, then what it will be? The difference between an atom's mass and sum of masses of its particle, and sum of masses of its particles. Now what we have to think, this mass is lost, then where it go? It lost somewhere in space or what? No. Actually, according to Einstein mass energy relation, here we have to write here delta m c squared, yani delta m according to our previous assumption m1 minus m2 unit, and this mass appears in the form of energy. It means if you have a proton, neutron and electron, when they form an atom, and this is the nucleus, proton, neutron and electron, so their mass is decreases. So this decrease in mass will appear in the form of energy according to mass energy equivalence. And this will happen inside, later on you will see inside the fission and fusion. Now another thing we have to know, for example, you have a nucleus, and inside the nucleus, for example, I am considering one proton and one neutron, and you would like to separate them. If you would like to separate the nucleus, then you need energy. Energy is required. So this energy that is used to separate the nucleon till infinity, we call it binding energy. Now a new term here now, binding energy. The energy required to separate the nucleon till infinity. This is what we call binding energy. So binding energy play an important role for the formation of the nucleus and in order to destroy a nucleus and splitting the nucleus. So whether you are forming a nucleus or splitting a nucleus, in both cases you required energy. That energy is known as binding energy is required. So when you would like to form the nucleus, then you have to supply energy, and when you would like to split the nucleus, the same amount of energy is released. So here, for example, you supplied energy E. Energy supplied to separate the nucleon. Then again, if you would like to split them, then the same amount of energy is released, and reverse will happen. When proton, neutron, electron combine, they form an atom. When they split, they will form proton, neutron, and electron. In case of atoms, in case of an atom, all these particles appears to be lighter, but as soon as they separated from each other, they become heavier. So it means the energy that you supply to split a nucleus, that appears in the form of mass. I hope you understood it. Wait for my next lecture about radioactivity, mass energy relation, and I will explain fission and fusion in detail. Thank you.